Hello friends, welcome to another tutorial in digital signal processing. In this tutorial we'll talk about correlation of discrete time signals. In the previous tutorial we talked about convolution of two signals, which is essentially the relationship between x of n, which is the input signal, and the impulse response of that system. So basically convolution is a little more complicated or a special case of correlation, but correlation of two discrete time signals is just the measure of similarity or the degree of similarity between two signals. And sometimes we can also measure the similarity or the degree of similarity of a signal with itself or with the inverted version of that signal. So that will be known as autocorrelation, that I'll talk about in a bit. But for the time being, you just need to remember that convolution is a very special case of correlation where we want to find the output of a system when the input is known and the impulse response of that system is known. Now, if we talk about the types of correlation, we have three types of correlation: cross correlation, which is going to be the correlation between two signals x1 and x2, and autocorrelation will be the relation between the signal with itself, and I'll show you how you take the inverted version of the signal to find the relation with itself. And then the circular correlation is the third case. Now if you look at the formula for correlation, it is given by R of k, and you simply multiply the first signal with the inverted version of the second signal. You can see it is x of x1 n, so this is x2 of minus n, and of course it is shifted and you vary n from minus infinity to infinity. So for whatever value of k that you wish to find the correlation, you simply put the value of k here and find this summation. And we have seen two discrete signals x1n and x2n. I'll show you the correlation, the types of correlation, with an example now. So let's take two signals x1 of n, which is 1 1 2 2 with its origin at 1. x2 of n is 1 2 3 4, origin of course at 1. Now important thing here is to understand that when we find the cross correlation using the cheat method, what you do is you first write down x of n, the first signal, vertically as it is. So I'll write down 1 2 3 4, but on the horizontal axis here you write down the inverted version of that other signal. So what will be the inverted version of x2n? That you need to find out very carefully. Now 1 is at the origin, so it will stay here, and 4 will come to minus 3, 3 will come to minus 2 sample, and 2 will come to minus 1 sample number. So this will be the inverted version of x2n. So this is very, very important to understand, because we are going to write down the inverted version of x2n, and that will be 4 3 2 and 1. And the rest of the process is very similar. You multiply 1 with 4 3 2 1 and write down in the first row, and then you multiply 1 with all the elements 4 3 2 1, multiply 2 with all the elements 8 6 4 2, multiply 2 with all the elements 8 6 4 2 again, and then we draw these diagonal lines and we add up the elements to find out the cross correlation between x1 and x2. So answer will be 4 and 7, and progressively we'll find all the answers. But the fact here is where will the origin lie? So the answer is pretty simple. The leftmost the leftmost sample will be minus 3 plus 0 will be at minus 3, and the rightmost sample will be at 3. So this has already been discussed in the previous video. How do you find the leftmost sample of the answer and the rightmost sample of the answer? And if this is minus 3, the leftmost, the rightmost is 3, so the center will automatically lie here at 17. So pretty simple, isn't it? And then we find the autocorrelation. As I mentioned, it will be the relation between the signal with itself and of course the inverted version. So if I want to find the autocorrelation between x1 and x1, so I'll invert x1, so it becomes 2 2 1 1, and the origin will be here at -1. This will be sample number -3 -2 -1, and of course x1 is 1 1 2 2. This is 2 2 1 1. I multiply this, so 2 2 1 1 2 2 1 1 4 4 2 2 and 4 4 2 2, and finally I draw these diagonal lines and I sum the elements in each of these diagonal partitions, and I get 2 4 7 10 7 4 2, and of course the origin will lie at this point because the leftmost element is -3, the rightmost element has a sample is placed at sample number 3. And finally, to understand the circular correlation, what you do is you take up the first signal that you keep as it is here, and the second signal, which you usually invert, you keep it here in this matrix, and you'll get the result here, which is going to be which will be shown as r dash x1 x2. So this will be known as circular correlation if we have a dash on top of it. But how do you write x2? What you do is you write down x2 as 1 2 3 4, and then you take 4 here in the next row as the first element, and then slide everything towards right. Then you get 1 2 3, and then you take 3 and you get 4 1 2, and then you slide 2 on the other side, 3 4 1. So you got the idea. You're basically moving in circles in rotation, just like you do the rotate instruction in microprocessor. And x1 will be written as it is. X1 will be 1 1 2 2. So this is 4 by 4 matrix, this is 4 by 1 matrix, and the answer is going to be 4 by 1 matrix. And when you multiply these two matrices, you get the first row with this column. So 1 into 1 plus 2 into 1 plus 3 into 2 plus 4 into 2 8, which is 17, and then 15, then 13 and 15. So this is going to be your answer. You can write down your answer here as 17 15 13 and 15. Here the origin will lie at the starting point because this is circular convolution, so we start from the first element as the origin, or whatever the order of x1 is. So I hope the difference between different types of correlations is clear, and that's about it for today's video. If you liked it, give it a thumbs up, consider subscribing. I'll see you around. Take care. Bye bye.